Hey there, builders and history buffs. Today we're diving into the heart of the Industrial Revolution, the steam engine. This incredible invention changed the world. It powered factories, trains, and ships, shaping the modern world as we know it. It all started with harnessing the power of steam. Before steam engines, people relied on muscle power, water wheels, and windmills. These were limited and unreliable. Imagine trying to power a giant factory with just your muscles. The steam engine provided a reliable, powerful alternative. It was a game changer. The steam engine is all about transforming heat energy into mechanical energy. It starts with a simple concept: heating water to create steam. This steam, under pressure, becomes a powerful force. But how do we turn that force into motion? Let's break it down step by step. At the heart of every steam engine lies the boiler, a giant, powerful kettle. Its job is simple: turn water into steam. Boilers are typically made of strong metals like iron or steel to withstand immense pressure. Inside the boiler, a fire burns fiercely, heating the water. As the water heats up, it turns into steam. This steam is trapped within the boiler. The pressure builds and builds. This high-pressure steam is the engine's powerhouse. Think of it like a pressure cooker. The steam inside wants to escape. The steam's desire to expand creates incredible force. The steam engine harnesses this force, directing it to do work. Let's see how this high-pressure steam actually powers the engine. Now that we have our high-pressure steam, we need to get it to the engine. This is where pipes come in. These pipes are specifically designed to handle the heat and pressure of the steam. They act like highways, guiding the steam from the boiler to the engine. Imagine these pipes as the veins and arteries of the steam engine, carrying the lifeblood of its power. The journey of the steam doesn't end there. It's about to meet the piston, the workhorse of the engine. The steam travels through the pipes with incredible force. It's ready to unleash its energy. But how do we translate this raw power into controlled movement? That's where the cylinder and piston come into play. Section 4. Directing the flow valves in control. Before we get to the piston, let's talk about valves. Valves are like traffic signals within the engine. They control the flow of steam, directing it where it needs to go. Imagine the steam rushing through the pipes. Valves open and close, guiding the steam into the cylinder. This precise control is crucial for the engine's operation. The timing of the valves is critical. They ensure that the steam enters and exits the cylinder at the right moments. This creates a cycle of pressure and release that drives the piston back and forth. But how does this back and forth motion translate into usable power? Let's find out. Section 5. Round and round we go. From piston to rotation. Now let's talk about the piston. It sits inside the cylinder, forming a tight seal. When the high-pressure steam enters the cylinder, it pushes the piston. This is where the real action happens. Think of a bicycle pump. As you push down, you're using force to compress the air. In a steam engine, it's the steam that provides the force, pushing the piston instead of your hand. This back and forth motion of the piston is then converted into rotational motion. This is where the crankshaft and flywheel come in. The crankshaft is connected to the piston. As the piston moves back and forth, it pushes the crankshaft, making it rotate. The flywheel, a large heavy wheel, is attached to the crankshaft. It smooths out the rotation, providing consistent power. Section 6. A cool boost, the role of condensers. Now imagine all that steam after it has pushed the piston. It's still hot and full of energy. Some steam engines use a clever device called a condenser to make the engine even more efficient. The condenser cools the used steam, turning it back into water. This creates a partial vacuum, reducing the pressure on the backside of the piston. This means the engine needs to use less power to push the piston back for the next cycle. Think of it like this. Imagine trying to push a door open against a strong wind. It's much easier to open the door if the wind is blowing in the same direction. The condenser creates a similar effect, making the engine's job easier and more efficient. Section 7. Transforming transportation and industry, a legacy of steam. So there you have it, the steam engine. This ingenious machine with its boilers, pistons, and valves revolutionized the world. It powered factories, allowing for mass production. It drove trains and ships, connecting people and goods like never before. The steam engine's impact on transportation was profound. Trains and ships could carry more goods and people. faster and further than ever before. This led to the growth of trade and industry, transforming the world economy. The steam engine's legacy is all around us. It's a testament to human ingenuity and our ability to harness the power of nature. So next time you see a picture of a steam engine, remember the incredible impact it had on our world.